Okay, certainly when you're on YouTube, you're going to see a lot of these tricks being done. And this is probably a popular one. It's typically not really taught at the Calc 2 level or Calc 3 level. It's pretty much avoided. I think maybe a lot more physics people would do it. But let's go through it. We've done this before, and certainly some use the letter T or letter B. Just don't use the letter X for this integration. And then I wrote this one over here with the understanding it's really the same thing if I'm doing this integration where the B is equal to 1. So really, this is what I want. I want this. This is what I want. And I hope you remember that we've done these before with this type of substitution. What I'm going to do now, I'm going to differentiate both sides with respect to B. Right, so I'm going to say the left side's really easy to differentiate. The right side a little more complicated. I do want to write it down for you, though. So really what we're doing is we're differentiating the integrand. Let me write this over here. So we're differentiating the integrand with respect to B. What's the integrand? It's sine cubed bx over x cubed dx. So let me repeat what we're doing. We're just differentiating the integrand. It really doesn't look bad to do. And let me write this down for you. It's going to be 0 to infinity. What are you going to get there? You can get 3 sine squared bx times, let's see, I just did the 3, right? And then I got to, I got to differentiate the sine, so that's going to be cosine of bx. And then I go to the inside, and that's just going to be, let's see if I did, just x. Wow, that's not that bad. Over x cubed dx. Well, pretty nasty. Let's do some simplifications over here. I'm going to say a 3 pulls out. I definitely get a sine bx, a sine squared, I mean. I definitely get a cosine of bx. One of the factors of x cancels, so I get x squared in the bottom, and then I get dx. I notice there's an error in my notes now. I want to point out right over here. That should be B. I'll make the correction if I can remember. All right? But I'm at that stage there. And then, again, the question is, what do you do with that? And, what we've done in the past, I guess one thing we could do is just take that sine function and write in terms of cosines. Let's see if that helps us at all. All right, so let's keep going. Again, we're working our way forward on this. So 3, 0 to infinity. The sine squared is the same thing as 1 minus the cosine squared of bx times the cosine of bx dx over x squared. All right, let's take a look at that and see what to do with that. All right, let's split it up. 3 0 to infinity. I would get cosine bx over x squared minus cosine squared bx cosine bx over x squared dx. All right. All right, what do you do now? Sure would be nice to reduce power. I don't want to go up in power, so you certainly get a cosine cube there. but I'm going to use those double angle formulas. Let's write that down for you. So cosine of 2 theta is 2 cosine squared theta minus 1, or cosine of 2 theta plus 1 over 2, and this is a reduction formula, is cosine squared theta. All right, let me see if I can write that down. So you get 3, 0 to infinity. Let's see, cosine bx, that's not an issue, over x squared, minus, and here comes the tricky part, and I'll tell you what I'm doing over here. I'm taking this, and I'm using this over here to rewrite it. And I gotta be really, really careful with that. And let me write that down for you. And that's going to be a fraction 2, and then I'll get cosine of 2bx plus 1. All right? Wow. Well, I'm going to common denominator. I'm going to put 2 here and a 2 there, and I'm going to keep massaging this thing. Hopefully I'm going to see something. And I want to tell you what I'm concentrating on. I got the same denominator, 2x squared. And what I'm concentrating, I got 2 minus 1 of them. So that's going to give me a common denominator of 2x squared. And then we're going to get, 2 minus 1 is just simply one of those things. All right, then what do you get? You get minus, let's be careful, cosine, I'm sorry, I want to make that 2bx. I want to make it clear. Cosine 2bx times cosine bx over 2x squared, dx is over here. Let's keep looking. All right, again, if someone says, what is this we're doing over here? We're still working on this part. I'm still working on it. So this is still I prime. All right, and we're basically just following the steps, by the way. All right, so then I always say that a lot of times things you don't remember what you learned in pre-calculus, and sometimes they're not learned because people see them as memorization skills. All right, but I want to write down 2 formulas that you probably should know from pre-calculus. You should know this, and you should know this. Now, again, if you're really good at memorization, you can say, I don't need to remember. I can derive these things. You can, but let me just write them down for you. So cosine A, cosine B, minus sine A, sine B. This one's going to be cosine A, cosine B, plus sine A, sine B. So someone says, why are you doing this over here? I'm just seeing if I can get, I'm seeing this thing as a product. And I want to see if I can write a sum down instead. All right? And so I don't see how this relates to that. It may not relate to it, but I do see a product and see if I can get a sum down. So what I want to do is I want to write down, a possible sum just by adding these 2 together. And let's see what we get. We get cosine A plus B plus cosine A minus B equals, well, when you add the right-hand side together, you're just going to get 2 cosine A cosine B. And that's not so bad. All right, so what I want to do is look at that and see if that helps me at all. So right below it, and again, I want to point out, we're still looking at this over here. This is the thing I'm wondering about. What do I do with that? So I'm going to say, I want to get rid of the 2. Whoops, a little too far there. And I'm going to put the 2 over here. And then right below this, I'm going to write down what I'm looking at. I'm looking at cosine 2bx and cosine bx. Well, I'm going to say the a, just, kind of looking at it, is this, and the b is this. All right, let's see what we get if we did that. You would get cosine 2bx, cosine bx. On this side over here, you definitely get a 2. That's not an issue. Then you get cosine. Well, it's a plus b. That's the big A plus big B. Is going to be 3bx. Plus the cosine of a minus b. Well, that's going to be 2bx minus a bx, which is just going to be bx. All right? So I'm going to pop that in and see if it makes it any better. And this was known as a product of sum formula. This is a product. This over here is a product. This over here is my sum. Let's write it down. And as I do that, I get really, really, really careful. So, whoops, that's not being careful by doing that. So I prime of b is equal to 3, 0 to infinity, cosine bx over 2x squared minus, give me a dx here, and I got to pop this in now. So it's going to get 4x squared, because I got 2 on the bottom there, and you get cosine of 3bx plus cosine of bx. Well, I'm going to try to combine those 2 terms together now, see if things get better. And the way to do that is I'm going to multiply top and bottom by 2. So this will become 4. This becomes 2. And let's see what you get. You get 3, 0 to infinity, 4x squared dx. And let's see, 2 minus 1 is just 1, so cosine bx. Again, 2 minus 1. And then it's going to be minus cosine 3bx. All right? I notice I'm mixing a lot of letters over here, and I want to point out, sometimes I'm writing B's and T's down. I don't know why, right? But I think I should stick with B. I notice it says over here, differential with respect to T. It really should be B. And I got to make some corrections in the notes, by the way. Let me see if I made that error up here. I don't think so. But I'll look over them again. By the times I'm looking, I don't see them. All right, so this is I. Whoops, cancel. Let me put that down. This is I prime B. Let's differentiate again. And what do you get? By the way, you may be questioning what's been accomplished. What's been accomplished, I got, really kind of 2 simple functions now, cosine, and they have no powers on them. I mean, really easy to differentiate it. So it's going to be 3, 0 to infinity. We're differentiating with respect to the variable b now. So actually you choose a constant. So what do you get? 4x squared, that's what you get in the bottom. And then what do you get? It's going to be sine of bx, let's see, times x. Again, we're different with respect to b, minus, whoops, I'm sorry about that. This is minus. This will be plus. Sine 3bx. Yeah, I'm jamming that in, aren't I? And that's going to be times 3x. All right, I got to simplify it because it looks nightmarish. So I can put 3 here, a 4. I'll tell you what I'm doing over here. I'm seeing the 3 there, the 4 there. I'm going to reduce by x now. And I still get 0 to infinity. And I reduce the x, so I get just x over here. That's taken care of. And then what do you get? You're going to get minus sine bx. And then on the other one, you're going to get 3 sine of 3bx. Okay? And now what I'm going to do is I'm actually going to split into 2 different integrations now. I think I recognize them now. So let's write this down kind of carefully too. 3/4, 0 to infinity. Well, you know what? If I pull a 3 out from the first term, it's just going to be 4. I'm actually going to write down 2 integrations, by the way. I'm sorry, it's not 4. It's daydreaming there. It's going to be 9/4. Sorry about that. And then you can get sine 3bx over x dx. I got to do that integration. And the next one I'd see is minus 3/4, 0 to infinity, sine bx over x dx. All right? So what I'm going to do now is I'm going to do u substitution. And I only want to do one at a time, by the way. I'm going to do this one first, and then I'll do the other one next. So the first one we're going to do is I'm going to make a u substitution u, and you can do this if you like, is 3bx. And by the way, I'm differentiating with respect to x now. So what's du going to be equal to? 3b dx. Let's write that down. So it's going to be 9/4. Now if x is 0, it starts at 0, and 3bx is going to go up to infinity. All right? Wow. You're going to get sine of u. I got to be careful here. What's x? It's going to be u over 3b. Now u over 3b, I'll put the 3b up here. All right, what's the dx equal to? It's 1 over 3b du. So these are going to cancel off. Do I recognize that guy? I do. All right, let's write that down. So it's going to be 9/4. Oh, you know what? Before I recognize them, I want to do the next one. Let's say we're done with this. Next one, I'm going to say u equals bx. Du is going to be b dx. And let's pop it in. What are you going to get? Minus 3/4. It's still going to go from 0 to infinity. I'm going to get sine of u. What goes on bottom? Well, looking at it, it's going to be u over b. So put the b here, the u there. And what's dx? The dx is going to be du over b. What happens there? The b's cancel off. And I'm recognizing 2 fairly simple problems that I recognize from prior problems, by the way. What do I recognize? Let me go back over this for you. And so as I don't remember, I'm really recognizing, whoops, not that guy. Sorry about that. I'm recognizing this guy, which is pi over 2. Let's write it down. And let's hope I didn't make an error. So this is 9/4 pi over 2 minus 3/4 pi over 2. What are you going to get there? Let's see. You're going to get 9 minus 3, which is 6 pi. Let me see if I did that right. If I did it right, 9/4 9 minus 3 is 6. I think I made a mistake somewhere. Let me see, 6 pi over 8, and this is I double prime of B. I'm going to say that's, I get to reduce it, 3 pi over 4. All right, I hope I didn't make a mistake with the number, but now what I got to do is I got to work back, and this is always a tough thing for me. So what I got to do, I got to work my way back, and I'm going to do it one step at a time. So it's going to be 3 pi over 4 B plus, I'm going to say C. I'm going to say that's some constant. I don't know what it is, though. Let me sit there. I did okay. Let's go back one more. All right, then we got to start thinking. This is going to be 3 pi B squared, 2 times 4 is 8, plus C times B plus D. All right. Now I got to remember, and sometimes I really can't remember, so I got to look it up. But I go back and say, what was IB though? I can't remember that now. Oh, it's right over here. Let's write that down. I lose track of where I am, by the way. So I'm actually running into the next problem too, though. So let me just see if I can write that down somewhere. So IB is the integration 0 to infinity sine cubed bx over x dx equals 3 pi over 8 b squared. I'm just copying this down over here, by the way. Plus c times b, big C times b, little b, plus d. It's all over the place, isn't it? So, what do? I say select b to be 0. And what would you get? What would I0 be? Well, if b is 0, that would be the sine of 0. And the sine of 0 is 0. So this is just going to be 0. Now, if b is 0, you're going to get 3 pi over 8 times 0 plus 0 times b, so you just get d. So d is 0. So I can get rid of that now. All right? So I just simply said, let me go back over that the b was 0. Now I'm going to pick another value. And let's set b to be 1 now. What are you going to get here? 0 to infinity, sine cubed x over x. And this is what I want. And if b is 1, I'm going to get 3 pi over 8 plus some constant. All right, I got to figure out that c now. And let's take a look. Maybe I know the C already. Let me think about that. Oh, I'm sorry. I selected the C to be. The B to be 0, so this would be let me just see if I said that right. IB equals this thing. And I did set something to 0, right? I wonder where I wrote that down now. Oh, it's over here. Oh, I see it now. Erase it. Let me think about this a second, though. Set B to be 0. It was a thinking problem at this point. I'm not really sure what to see at this point. But you know what? I do have this down. I know what IB is again. If you select, I guess I could go back one. I guess I could go back to this guy over here and set the B to be 0 for that. To find out what the C is, by the way. All right, so let me just do that. See if I can do that. And I prime B is 0. Yeah, I could do it here. If B is 0, this would be 1 minus 1, which would be 0. All right, so yeah, the C is 0 too. All right, so I'm pretty convinced that my answer for this one over here, that the C is also equal to 0. So we got this answer over here. Let's take a look at the key, or what we've got over here. We have that answer over there. I also want to point out, using Sage, which, certainly I can't say I rely upon it, but I do like to have something to go back on to see what it says the answer is. And this was a tough problem for me, I'll be honest with you. There's a lot of things to think through, sum formulas, difference formulas, product of sum formulas, all kinds of nonsense in the problem. Figuring out the parameters C and D took some time and effort, but eventually we got to this over here. Thank you.